In this video, we will discuss the topic of solubility and its defining factors. The amount of a substance that will dissolve in a given amount of solvent is defined as solubility. There are three types of solutions that can help describe the amount of a solute in a solvent: unsaturated, saturated, and supersaturated. A saturated solution has the maximum possible amount of solute dissolved in the solvent. Let's take a closer look at the process of forming a saturated solution. Here we observe the process of a solute dissolving in a solvent. This process is known as dissolution. The solute molecules initially begin to dissolve in the solvent. We can observe that as the number of the solute molecules in the solution increase, some of them collide with the undissolved solute and recrystallize. This process is called recrystallization. At the beginning, the rate of dissolution is greater than the rate of recrystallization, but a point is reached when these two rates become equal and are in a state of dynamic equilibrium. We can imagine this phenomenon using a balance beam visual. The increased concentration of the solution causes some of the solute to recrystallize in its solid form. Eventually, the system will establish dynamic equilibrium, which is when the rate of dissolution is equivalent to the rate of recrystallization. At this dynamic equilibrium, the solution is said to be saturated. Now that we can describe that a saturated solution is at dynamic equilibrium, it is easier to assess that an unsaturated solution contains less than the equilibrium amount of solute. Therefore, more solute is able to dissolve. A supersaturated solution contains more than the equilibrium amount of solute and will therefore cause the solute to precipitate out of solution. In other words, the maximum solubility of a solute in a certain volume of solvent is equivalent to the amount of solute it would take to make a saturated solution. The solubility of solids is affected by temperature. The solubility curve shown shows the temperature of the solution versus the solubility of the solute in grams of solute per 100 grams of H2O. Each different colored line represents the solubility of a certain solute. Although not all of the lines are linear, we can see the trend that as temperature increases, the amount of solute able to dissolve in 100 grams of water increases. Therefore, as temperature increases, the solubility of the solid increases. A certain problem may ask you to determine how many grams of potassium chloride are soluble in 150 grams of water at 10 degrees Celsius. First, we need to write down the important information and what the problem is asking you to find. We know that we're being asked to find the grams of KCl that are able to dissolve in 150 grams of water at 10 degrees Celsius. Then you can use the solubility curve to find the solubility of KCl at 10 degrees Celsius in 100 grams of water. Going over on the x-axis to 10 degrees Celsius and moving straight up until we intersect the line corresponding to KCl, marking that spot on the KCl solubility curve and moving horizontally to the y-axis, it can be determined that the maximum amount of KCl that can be dissolved in 100 grams of water at 10 degrees Celsius is 30 grams. You can then use this information as a conversion factor to convert grams of water to grams of KCl. Therefore, we can see that if the mass of the solvent, in this case 150 grams of water, is multiplied by the conversion factor, the unit of grams of water will cancel and lead us to determine that 45 grams of KCl is soluble in 100 grams of water at 10 degrees Celsius. So overall in this video, we have discussed the topic of solubility and the factors such as temperature, which will affect the solubility of a solid. We must keep in mind that a gas's solubility in solution is affected by temperature and pressure, which we will discuss in the next video.